or Kathy is Canadian. Okay? So once again, we have two different statements. Okay? There's a couple ways that we can define this. Okay? So, what's one way that you guys might define the first statement?
Sean is tall, then not signed before.
Yeah, we could do Sean is tall, or we could do Sean is not tall, right guys? If we do Sean is tall, then we have to put the negation of that when we go to do it, okay? And then obviously the other one is Kathy is Canadian. Canadian. So if we had those definitions, then what we would say is not P, and since it's an or, we have the upside down caret or just the V, and then Q. Okay, so like I said before, guys, without the definitions of P and Q, if you just put that last statement there, not P or Q, unfortunately that wouldn't be correct. Okay, you have to define P and you have to define Q if you want full credit. Okay, all right. So any questions, guys? I can answer about that one. Pretty straightforward. Okay, yes, sir.
Why is P not, Sean is not tall?
It could be, okay? So it just depends on how you define it, okay? So, sir, if, let's say for some reason, you defined it as P is equal to Sean is not tall. And then you said Q is equal to the same thing as it was before. Then you would just say P or Q. And if you did that, that's perfectly fine, okay? And so it doesn't really matter which way you define it. I'm okay with either way. So both of these would be perfectly acceptable. Just like if you guys were writing a computer program, maybe you just said you don't want something to happen. Okay, you could define it a couple ways. So does that make sense, sir? Okay, you could do it either way and you'd be fine. Okay. All right, other questions, guys, I can answer? Okay, for the last one, a letter C. If I am rich, then I'm not a teacher or I am a politician. Okay, So I think in this one, there's probably going to be three simple statements, aren't there, guys? The first one is I am rich, not if I am rich. So let's let P be equal to I am rich. Okay? Because remember, a statement is something that's either true or false, but not both. If it says if I am rich, I don't know, what does that mean? That's not even a complete statement. Okay? Define Q to be either I am not a teacher or I am a teacher. Let's just say I am a teacher. And then finally for R, we can define R to be I am a politician. Not saying this is the only way to do it, just saying that this is one way to do it. You could have defined Q to be I am not a teacher. Okay? So if I was to ask one of you guys to write this in symbols as opposed to writing it in the sentence form, does somebody think they can use what I have up there to write it? Go ahead, sir, please.
P and then conditional, and then negation, Q, disjunction, R.
Nice. All right. It doesn't matter if you have parentheses in this one, okay? But generally, it might be helpful to put parentheses after that, just so it's grouped together. Although, like I said, in this problem, it's okay to do it without the parentheses, okay? Because the order of operations, okay? Sir?
It almost seems a little bit unclear if it doesn't have parentheses to me, though, because that end sentence kind of is
Right.
one.
The order of operations says that you do negation first, then you do disjunction or conjunction, then you do the implies or the conditional, okay? So that's, so for this problem it would work, but for other problems it might not, okay? My suggestion is, guys, use parentheses regardless, just to make it easier for you, okay? And we haven't gone through the order of operations yet, so you guys wouldn't know anyway, okay? All right, so questions I can answer for you guys about before we go on and we start talking about truth values and compound statements and that sort of stuff. Okay, really easy stuff to start out with, right guys? But all we're doing is we're just defining these so that we can move on and start talking about more difficult stuff. Okay, so some more fill in the blank stuff. So when we talk about a truth value, truth value is going to be the value assigned to some sort of statement. Okay, so let's just start over again. We'll just start at 1. So this is a truth value. Okay? So truth value is going to be the value that's placed on some sort of statement. Okay? There's only 2 truth values, either true or false. There's no opinion, there's no maybe, there's no I'll do that next week. Okay? It's either true or false, or if you want to use 1 or 0. Okay. And for those of you guys that are computer minded, you like 1s and 0s better because that's binary. Okay. So whichever one you want to use, I don't care. Okay, I can figure them both out. Okay. For it to be true. Okay, so let's go back to the table that we had earlier, and let's kind of think about these guys right here, these logical connectors. Okay. So which of those 4, if I go back here, which of those 4 do you guys think has to be true? If I had 2 statements together, which of those has to be both true for the entire statement to be true?
And
Yeah, the and statement, right guys? Or in other words, the conjunction, okay? So, for a conjunction to be true, both of the simple statements must be true, okay? Like if I told you guys, okay, I have a blue marker and I have a black marker. They both have to be true for me not to be lying. If I say something like, I have a blue marker and I have a magic baton that when I zap you, you're going to get 50,000 volts through your body, okay? One of those is a lie, okay? Thank God, all right? So that would not be a true statement, okay? So, if I wanted to say, and I'll scroll back down, okay? For a blank to be true, either statement or both statements must be true. So which one is that, guys? The disjunction, right? An or statement. So next to conjunction, I'll put and. Disjunction. For a disjunction to be true, only one of the statements at minimum has to be true. They both could be true, okay? Like for instance, if I said, I have black marker, or I have magic wand that's going to zap 50,000 volts through your body, okay? I'm not lying to you because I have one of the 2, okay? A lot of times it's just dependent upon what we want to utilize. We're going to see that later in the course, okay? So for conjunction, both of the statements must be true. For disjunction, at minimum 1, they both could be true, okay? And then finally, for a blank to be true, then the statement must be false. So that would be which of the 4 that's left over, or which of the 2 that's left over. Negation, right? For a negation to be true, the original must be false. Okay, so I think one of the most basic sorts of instruments that we can utilize in logic is a truth table. Okay, truth table is very foundational. Okay, it's almost like add, subtract, multiply, and divide when we talk about arithmetic and algebra. Okay, and even calculus. You have to know those things before you can do anything more, and that's the same thing with a truth table. Okay, so basically a truth table is going to be all the possible permutations that can come out from n statements in a compound in a statement form. Okay, could be simple, could be compound, could be a whole bunch of them. Okay, if there are n simple statements, there are 2 to the n rows in the truth table. Okay, so for instance, our second example, we have 2 simple statements. That means there would be 2 squared or 4 rows. If I was to construct a truth table for our third example, there are 1, 2, 3 simple statements, which means there are how many rows, guys?
8.
8 rows, because it would be 2 to the third. Okay? So one of the things you guys might want to do is before you even start doing the truth table, think to yourself, how many rows are there going to be? Basically, however many different letters there are, that's how many rows there's going to be. Okay, that's as easy as it gets. I'll show you guys an ordering for this. All right. I want you to notice that on the notes that we have. Okay, one of the first things I want to make sure of is that if I give you guys a simple disjunction or conjunction or some sort of conditional or negation, that you guys are able to figure out the truth values for those. And I think we've already done that, but we can fill these in, okay? So let's say we're talking about the conjunction. Guys, what did we say has to be true for a conjunction to be true?
Both have to be true.
Both of the statements must be true. So, for P and Q to be true, a true and a true, real nice, gives an output of true as well. Okay, sorry, this isn't lined up well. Okay? The other 3 of those are going to be false. As soon as you see a false in a conjunction, the rest of it's false. Okay, so let's get the better as I do now. It's not quite done. Okay? So the first one's true. Sorry about that. I know it's not good, but we'll just blame it on the line for this thing. That's no better, is it? Okay. So let's talk about a disjunction. Okay? What did we say has to be true for a disjunction to be true? At least one, right? Or even both, right? So if I was to ask you guys to fill out the truth values for this, okay, what would be the 4 truth values for a disjunction?
True, 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 false.
True, 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 false, right guys? Okay, so this would be true, this would be true, this would be true, and this would be false, okay? So for a disjunction, only one has to be true, okay? All right, now for implies, okay, this is the one that tricks a lot of students, okay? The way that I think, or let me ask this first, maybe somebody knows already because they've seen it before. Does anybody think they might know what the truth values are for a conditional statement? Go ahead, sir.
Is because the tricky ones is false implies true. That's the tricky one. So it's true, true.
True, false, true, true. No,
Is it true,
true,
false, true, true?
It is true, false, true, true. Okay, that's okay. I'll explain why. True, false, true. Okay. That's the only one that's steep. Okay? Yeah, and then you're probably like, okay, I can't remember like in my head like which. That's okay, no big deal. Think of this statement, okay? If I study, you don't have to write this down. I'm just justifying this. Then I pass. Okay? If I tell everybody in this class, if you study and do what you're supposed to do, then you will pass. Okay, that's my promise to you. Okay? Let's think about this. Let's say you study and then you pass. Do you get what you deserved? Absolutely, right? I promised if you study, you will pass. What if you study, in other words, the first part's true, but the conclusion is false? Have I held up my end of the bargain?
no.
I have not. So that's why, if you study, you do not pass is false. Okay? Now, think about this. What if you don't study, but you do pass? Did I lie to you guys?
No.
No. Okay? I mean, you still passed the course without doing anything. Okay?
But
So
you
I
did.
didn't lie to you. What if you didn't study and you didn't pass?
That's true.
That's true, right? I told you, if you study, you'll pass. If you don't study, you're not going to pass. So if you're ever on like an examination or sitting there for your homework, okay, I always tell students, think back to this statement. If I study, then I pass. And just think about, if I promise that to you, what happens if you do or don't do what you're supposed to do? Okay, so does that make sense as to why it's arranged like that? Okay, and some of you guys might have never seen this before, but it is what it is. Sort of. Okay, and then the last ones are negation. So the negation's easy, right guys? If the original statement's true, what's the negation? False. And if the original statement's false, the negation is true. Okay. These you guys should at some point memorize. And when I say at some point, I'd say as soon as possible. Okay, so these are ones that you guys are going to be fundamental to us being able to do the rest of the problems. All right, questions I can answer before we go on and actually construct truth tables from more difficult statements. Okay, so this is more likely as to what you guys are going to see like on a quiz or on your homework and on your examinations. Okay, to where I give you guys some sort of statement form, and I want you guys to write some sort of truth table for that. Okay, some of you guys have done this before, some of you guys haven't. So if I'm moving slow with this, I'm not trying to insult your intelligence. I just want to make sure you guys are okay with this. Okay, so I'm just going to do it on the board, but obviously you guys can do it in your notes packet. All right, I look at this statement. How many unique, simple statements do we have in this statement form, guys?
2.
Not 2, but
3.
3, right? We have P,
Q and
R.
R.
The not P doesn't count, okay? So that's probably the one you were thinking of, right, sir? Yeah. Not P is just a negation of it. So there are 3 statements, which means how many rows are we going to have?
8.
8. So we have 3 statements, which implies 2 to the 3rd rows, which should be 8. Okay? So, like I said, even before you start the problem, it might be viable for you to think, how many rows are we going to have? Okay? All right, we have three simple statements. We have a P, we have a Q, and then we have an R. Okay. I don't know if this is helpful, okay? This is the way I always arrange it because I think to myself, okay, there's got to be 8 rows, okay? So, the way I think about it is the first 4 of the P's should be true. The second 4 of the P's, false. And by the way, this is an algorithm to where you guys get all of the different permutations for this, okay? So the first 4 true, second 4 false. Then instead of going in groups of 4, we go in groups of 2, right? So I'm going to do true, true, and then false, false, and then true, true, and then false, false. What should I do to get all the permutations with the column R?
True, false, true, false.
Yeah, just keep alternating, right? Because if you think about it, doesn't this go in 2 squared? So that's how many trues I should have in a row. Doesn't this go 2 to the first, which tells me how many trues I should have in a row? And this would be 2 to the 0, okay? So basically, guys, if you ever had, let's say for some reason you go into like you have like some crazy guy that wants you to do like, I don't know, 5 variables, which would be 32 rows, then what you would do is you would do 16 trues, 16 falses, and then 8 trues, 8 falses, 8 trues, 8 falses. So you just keep going in descending powers
Oh,
of
so
2.
truth table n minus 1, that's how you do
That's
it?
exactly right. And n minus 1 being the previous number of truths in a row, okay? So this would be true, false, true, false, true, false, true, false. And I'm just doing this. And I'm trying to use the different colors just to indicate when you guys should